All right, hello everyone. Today we are working with logarithmic equations. We have two equations here. We have like two different scenarios. So the first equation, part A, is going to be using this property and I have written in red here, which says that if you have the log of two bases on two sides of the equation and they equal each other, then the insides have to each other. This is a property of logarithms that they're 1-to-1. So in our case, with part A here, we would have that log base 5 of x plus 1 equals log base 5 of 4x minus 7 implies that x plus 1 would equal 4x minus 7. And you would go ahead and just solve like you normally would. It's like the way we like to say when we're solving an equation, a method when you get to this step where you have something familiar to work with. So I'm going to add 7 to both sides, get all the constants on one side, and try to get all the x's on the other. So I'd have x plus 8 equals 4x, and then I'd subtract x over to the other side, and then you get 8 equals 3x, and x equals 8/3. Now, you would technically want to check your answer here, because it is possible that your answer gives you something that's undefined, okay, inside the log. Now, what you really need to check for is the inside of the log, that it's not negative. So if you go to the part where it's x plus 1, you get 8/3 plus 1, that's positive. And then the 4x minus 7, when we plug in the 8/3 there, that's like 32/3 minus 7. That is going to be like 11/3. Okay. That's positive. So that's what you need to do. Is you want to make sure that whatever answer you get keeps the logs inside being positive. All right. Now for the next equation, what we're going to do is as follows. We're going to use this property, which says that if you have a logarithm, you can rewrite it as a exponent. And in this case, the way it works is that b to the c power equals a. Because a logarithm at the end of the day is giving you an exponent. And the log basically means that if you take this base c and you raise it to c, you get a. So in our case, with problem B, we had log base 3 of x plus 1 minus log base 3 of x minus 1 equal to 3. You could use this property, however, not yet. We're going to use it. And the reason we can't use it yet is because of the fact that you have two different, not two different, but two logs that you can actually write as one. Okay, so you have a subtraction between these two logs with a common base of 3. So what you're going to do is you're going to rewrite this as the log base 3 of x plus 1 over x minus 1, all equal to 3. I'm using the division rule or quotient rule with logarithms. And what I'm going to do now is I'm going to apply that property that I have in red. So once again, if we scroll up, we can rewrite this out as, using the rule, 3 to the 3rd power, because my base is 3 and my exponent is 3, equals x plus 1 over x minus 1. So we get 27 equals x plus 1 over x minus 1. And yeah, I could go ahead and multiply the x minus 1 on both sides. I usually don't want to work with variables on the denominator. You get 27x minus 27 equals x plus 1. So you get 26x equals 28. And x would equal 28 over 26, which would give you 14/13. And once again, you would check 14/13 back in the original equation and just making sure that it doesn't make the inside equals to 0 or negative. So check log base 3 of x plus 1, so 14/13 plus 1 That checks out. Again, I really don't need to know what this is. All I need to know is that the inside would be positive. And the other log had x minus 1, so it'd be 14/3 minus 1, which is positive as well. So this would be a solution, okay? All right, so once again, just to kind of recap what we did, when you have logarithmic equations, you will follow two ways of looking at them. It depends on the equation, two techniques, excuse me. So the first one is when you have two logs equal to each other, you can just set the insides equal to each other. That's what we did. And in these cases, it's pretty simple. And if it's not the case, like it was in B, you use the fact that you can rewrite a log as an exponent, but what you do is you rewrite the logarithm first using laws of logarithms, and then you use that property, okay? And this is very common with logarithmic equations when you're asked to solve these problems. You're gonna add or subtract logs, and you gotta put them together using the rules, and then do the step that we did that's highlighted in red, okay? Thank you for your time.